Hello, good afternoon. Hello, everyone. Hello, Charles. Hello, Akiri. Hello, Nurzin. Hello, Bungamusa. Bungamusa representing Zimbabwe. Charles from Uganda. Two countries I've not yet had the pleasure to visit. Exercise 2. Adding and subtracting. So let's talk about adding and subtracting again. So remember that you want to return a point. You want to take a point and another point and add them together and return another point. Not a tuple, we want to return a point. Are you getting a score of 1 on the first exercise? If you're not getting a score of 1 on the first exercise, well, we need to go back and fix things so you do get a score of 1 on the first exercise. And you need to carry over that repr method from question 1 into question 2. Yeah, sorry about the problems with the servers. As soon as we knew about the problem with the servers, we looked into it. It seems that the problem with the servers was largely a problem with our service providers. That problem with the service providers seems to be resolved at the moment, but we're continuing to keep an eye on things. Did you copy over your repr method into exercise 2? I don't know that I could make anything more clear than it already is. I made things a bit bigger. Yeah, we'll work on the distance exercise in a moment. But remember that you need to carry over the repr method from question 1 into question 2, right? We're adding more functionality to this class. If you haven't carried that over from question 1, that may be why you're getting a 0 on question 2. So make sure that you are doing that. Otherwise, I'm not entirely certain what else I could suggest at the moment. For the purposes of this exercise, we could assume that other is going to be a point. For the purposes of this exercise, you don't really have to write this more complicated add function. I was just trying to demonstrate how we the programmers have the power to define this function to behave however we'd like in general. So I could write this add function to handle adding a point to another point. Got to make sure we add the x components and we add the y components and that we create a new point. If we wanted to do so, well, we could give some meaning to what it means to add a point and an int or a float. As I said, I chose to allow that to happen, and I add this int or float to both coordinates. And otherwise, I return the special non-implemented. Again, we don't need to do that for the purposes of this exercise. That's your problem at Carey. You can't assume that these are integers, and it looks like you're missing a space after the comma. After the comma in the string. So I think there's two things. One, you don't want to assume that x and y are integers, which is what %d is doing. My suggestion is to use the format method or to use f strings. And it looks like you're missing a space after the comma in the string. So we talked about addition, subtraction. I defined a negate method, which again isn't necessary for the purposes of this exercise. But I stuck it in here anyway. We talked about subtraction. We talked about multiplication. Multiplication, we have to handle, the situation of multiplying a point by a int or float. And we have to handle what we mean by multiplying a point and a point, where we do the inner product to return a number. And again, we don't have to define an RMUL method, but I was again demonstrating why we might want to do this and how we want to do this, to give lots of functionality to this class. The mul method lets us do this, a point times a int or float. The RMUL method lets us do this, where I have an int or a float times a point. The order matters when Python is attempting to execute these operations. So again, make sure you copy over all this code correctly from your other exercises. And we want to add in a distance method. Looks like you still might be missing a space, but I can't tell from that code. So we want to define a distance function. We want to define a distance function right here as the normal Euclidean distance between 2 points. So this should return a number. All right, I take the difference of the x components and square it, add the difference of the y components and square it, take the square root and return that number. So the distance right here is going to be another point. I can't change the resolution. I might suggest reloading your web page if things aren't clear. Apologies, but I don't think there's anything on my end that I could do. So the distance function, we're going to have two arguments yet again. And again, I don't have to do this, but I'm going to check is instance other a point. Then I want to do something. I want to return something here. Else I'm going to return not implemented. What am I going to return? Well, I want to do the following. I'm going to, first of all, import the square root function from the math package. And then what I'm going to do, well, is I want to take the difference of the x coordinates and square it, add the difference of the y coordinates and square it, and take the square root. So SQRT out front right here. Right, so again, difference in the x coordinates and square it. Add the difference in the y coordinates and square it, and take the square root of the whole thing. I could easily check, well, some examples. I could, 0.10 and 0.1. T1 dot distance PT2. If I get the square root of 2, that's good. PT3 is point. I can't clear the camera lens. The lens isn't looking at my screen. -1, 0. PT3 distance to PT1 is 2. Good. PT3 distance PT2 should also be the square root of 2. Right, this is how we square something in Python, or this is one way that we could square something in Python, is to use the double asterisk. Right, 3 raised to the power 2 is 9. 4 raised to the power 3 is 64. So don't forget the square root. Why is my cursor not working? What's going on here? Why is my computer running slow? Apologies. Let me see. Here we go. All right. Let me stop something on my computer. Stop. If I try PT4 is 0.11, PT4 distance to PT1 is 1, yep, PT1 is 1, 0 and 1, 1, well, distance 1. PT5 is minus 1, 1. PT5 distance PT4 again should be 2, yep. And of course this should be symmetric, PT4 distance to PT5. Oops, let's print out both of these things. So the distance function should be symmetric. The distance from point A to point B is the same as the distance from point B to point C. All right, so any questions on how I'm implementing this distance method right here? It's just applying that definition. Take the difference in the x components of the 2 points and square it. Take the difference of the y components and square it, add them together, and take the square root of the whole shebang. So, you know, I could now, with my complicated operations, I could say PT1 plus PT2, which will return a point. I could find the distance to PT3. Right, this right here will return a point object. This point object I could call the distance function to get a distance to another point. Or indeed, you know, I could add multiple points together and, or, you know, add, subtract, multiply, divide, minus 2 times this point, 3, etc. Right, so my point class has even more functionality now with this distance method. Is there any question on what I've done here? And, you know, right, the idea of the not implemented is I could say PT1 distance to the number 4, but that's, oops, else return, else, oops, sorry, return, am I missing a return somewhere? Have I misspelled? Why am I seeing not implemented? That's strange. Should be raising an error. Oh, I see. Not implemented. Interesting. Oh, interesting. All right. Not implemented is good for the built-in binary operations. I would need to find out what kind of error I might want to raise here. Instead of returning not implemented, I guess I'd want to probably raise a value error or something like this. Raise value error not defined for that argument. Name error value. Oops, I can't spell value error. Not defined, right. So I see not implemented is only useful, is only relevant if I'm defining these dunder operations. Otherwise, I want to raise some sort of error, some exception myself. Interesting. Okay. I learned something new today. Anyhow, we could talk about this last problem. So yesterday I talked about this problem on an abstract fashion. Now we want to actually solve this problem. Right now we have a point class which can compute distances. We could use in all these operations. Most importantly, we need this distance method for this clustering problem that we want to define. So, as we said here, we might want to do with a data set is to separate the points into groups of similar points. So we're going to implement an iterative algorithm to do this, which will be a specific case of a general k-means clustering algorithm. If you don't know what general k-means clustering algorithm is, well, the description follows for two clusters. It says here the algorithm will require us to keep track of two clusters, each of which will have a list of points and a center, which is another point, not necessarily one of the points we are clustering. We make some initial guess for the center of the clusters. We're actually provided some initial guesses right here. And what you do is the following. So, as it says here, assign each point to C1 or C2 based on whether the point is closer to the center of C1 or C2. Recalculate the center of C1 and C2 based on these points. Provide a reference here. How do we recalculate the center of C1 and C2? We take the so-called center of mass of the points. And apologies for a moment, but I need to close the shade as the sun is coming in on my eyes. So, as I said, we want to recalculate the center of the cluster by taking the center of mass. This algorithm will terminate in general when the assignments no longer change, right? Because we assign each point to a cluster based on the closest distance, recalculate the center of C1 and C2, and then we return to step 1 and do this again, right? We basically want to reset the clusters, if you like, to, kind of remove the points from the clusters. But we have to do this carefully. So, as we said, the algorithm will terminate when the assignments no longer change. So we're going to initialize one cluster at 1, 0 and the other at -1, 0. This is what we're asked to do. The return value should be the two centers of the clusters ordered by greatest x value. Return these as a list of numeric tuples. So there's an init method, which we want to define. There's an update method, which we want to define, and there's an add point method that we want to define for a cluster class. Once we define the cluster class, we have to add a bit to this compute result. This is nearly doing the right thing, but we need to add some code here, add some code here, and add some code here, and we want this code to be, correct. And I need to change this return statement here to return the centers of these two clusters ordered by their x components, ordered by greatest x component. So a cluster object is we're going to have a center. We're past initial values for that center. So we create a point, an instance of this point class. The cluster is going to store a collection of points. Easiest way to do this is to store the collection of points as a list. I need an update method which will update the center of the cluster using the points that are contained in this list of points. So remember, after updating the center of the cluster, you'll want to reassign the points and thus remove the previous assignments from the clusters. So this update is basically going to do two things. One, it's going to update the center of the cluster. Two, it's going to reset this set of points to be an empty list. So what I could do is I could use the Python sum function, but I need to initialize this. The sum function normally starts, if you don't specify, starts with the number 0. I could do that here, but point 0, 0 is probably a better way to do this. I'm going to compute the sum of these points, and I look at the length of these points, and I want to update the center of this cluster to make a new point. So this is the center of mass. Right? I basically sum the x components and divide by the length. I average the x components, and I average the y components, and I create a new point. So this will update the center of mass of my cluster, the center of my cluster. And I'm going to reset my list of points to an empty list. So my update method, as it said, update the center of the cluster given the points contained in this attribute. So we update the center of the cluster. You want to reassign the points and thus remove previous assignments. I'm removing previous assignments by setting this list to an empty list. I need a method to add a points. Well, this is easy. My points attribute is a list. So I will append this new point to my list of points. So this compute results, well, it says this points right here is coming in, is going to come in as a list of tuples. I convert these things to elements of this point class. Note carefully the distinction between the uppercase P and the lowercase p. And so, you know, uppercase P. Nope, we don't need a return function. We're not returning anything here. This add point is just going to append this point to this list, and that's what it's designed to do. The update is just designed to update the center and to basically reset this list to an empty list. There's nothing to return. So we generate this list of points from this collection of tuples. We initialize our two clusters, set this old list to this empty list. I'm going to keep track of this so that I could stop my function early. Right? This is stopping the function early. So I go for a number of iterations, but the idea here is, well, I'm generally going to stop early. I stop when my set of points in the A cluster doesn't change, because, well, a point is either in the A cluster or the B cluster. If the A cluster doesn't change, well, everything that isn't in the A cluster is in the B cluster. Because this is what I'm doing here. If this point is closer to the center of cluster A than it is to cluster B, then what will we do? We'll say A, add point. We're going to add this point to cluster A. Otherwise, we'll add this point to cluster B. Now I want to update this A old. I'm going to do this in a way which is a bit careful to make sure that I don't lose this list. And what I'm going to do is I'm going to iterate over this A.points is a list. I'm going to create a new list of these points. Nope, A old is I for I in A.points. I need to keep track of this old list of points to see, am I done? So the for loop right here is adding my points to the cluster. I check, am I done? If I'm done, the break will get me out of this for loop. If I'm not done, I want to save my current list of points. And I want to do this before I update my cluster, because when I update my cluster, I'm setting this list of points to be empty. Now, remember, why am I doing this? If I did A old equals A.points, if I did this, these are effectively pointers. They're pointing at the same list in memory. Basically, I'm just trying to avoid any sorts of problems because lists are mutable. Right, I save the old list of points, I update the cluster A, I update the cluster B to recompute the center of the cluster, empty the clusters of points, and go again. Let's try one thing before so point 10, 34, fine. I don't think the tuple operation is going to like this because, yeah, this isn't an iterable. So now I want to return something. All right, let's return my results. I'm going to compute my results here. If A dot center dot x is greater than or equal to B dot center dot x. Result is, result. Boy, why can't I type today? I want A dot center dot x, A dot center dot y as one tuple, B dot center dot x, B dot center dot y dot y. I probably don't need to do this. The center, the x coordinate of A is larger than the x coordinate of B. I don't think they're going to change during this process. But I could double check. So B, A, compute result 10, 0, oops, a list of tuples 10, 0, 12, 1, minus 1, 2, minus 3, minus 2. I'll stick in another point, minus 1, that's 2. Right, like this one cluster here, the A cluster is going to have 2 points in it. Because these are going to be closer to the point 1, 0. These other points right here are going to be closer to the point minus 1, 0. Right, I should be easily able to 0, 0. That will put that point 0, 0 in cluster B. Because if the distances are equal between the 2 points, it's putting it into cluster B. Let's just try, out of curiosity, A dot points. See if this might break. No, that's fine because we're resetting this here to an empty list. We're not calling the clear function. That would be bad. Some of you have posted code where you're calling the clear function, and that's the wrong thing to do here. If you're doing this kind of thing, you're then basically clearing out this list. If you're calling the clear method here, you don't want to do that. Remember, lists are mutable. If you do this, then you have 2 things pointing to the same location in memory. If I mutate the list by operating on A dot points, I'm mutating the same list that A old is pointing at. I don't want to do that. This right here is basically, one way of helping to avoid that problem. I'll create a new list with the individual elements in this other list. So A old is a new list. It's in a different location in memory from the A dot points list. Right? As I said, this is better than calling the clear method of a list, because the clear method mutates the list. Is there any question on what I've done here? Right, I'm doing this iterative process. As I said, we make an initial guess at the center of the two clusters, go through the set of points, assign each point to one cluster or the other based on whether the point is closer to the center of C1 or C2. If there's a tie, we have to break the tie in some way. You know, we kind of arbitrarily decided, all right, if it's equally close to A and B, I'm going to assign it to B. After assigning each point to the clusters, then we recalculate the center. As I said, based on the contained points, we recalculate the center by basically taking the average of the x coordinates and the y coordinates of the points in the cluster. Don't include the center. I mean, the center may turn out to coincide with one of the points in the cluster, but don't include the center in these calculations. So we update the center, we clear out the set of points in that cluster so that we're ready to go again for the next iteration in this clustering procedure. I want to stop this clustering procedure early as soon as my cluster doesn't change. And this is one way that I could do that, right? So I need to keep track of the set of points that's in one of my clusters. We initially set this equal to the empty set. We check, is the old clustering the same as the new clustering? If it is, well, we're done, and we're ready to return our results. If we're not done, then we update the old collection of points, update the clusters, and go again for another step in this clustering procedure. This is, k means clustering when k is equal to 2, when I have two clusters. If I change the starting points of my clusters, I could end up with a different clustering as a result, right? Especially think about if I leave A at the point 1, 0, and I shove B way out to the left, minus a billion comma 0, well, then all of these points that I start with right here will go into cluster A, and they will all remain in cluster A. And my clustering will just, all the points will be in cluster A, and cluster B will be empty. So the final clustering that I end up with could very much depend upon the starting locations. Right, I'm trying to think if I have any other comments to make about any of these problems. As I said before, you want to make sure that you're copying and pasting your code from before so that you're not somehow changing something that used to work into something that doesn't work. I could raise this value error. I'll probably want to give a better error message here, right? Not implemented is only useful for the dunder methods, apparently. So if I want to do this, well, I say if I want to only do this if the other element is a point, well, then I would need to raise this value error instead. Or some kind of error message here. Right, so as I said yesterday, implementing an object could potentially involve writing a lot of code. As you can see right here, we wanted to write a lot of code so that we could add points. We also wrote more code so we could define what it means to add an int or a float. And the radd is so that I could have a float plus a point. The add will take care of a point plus a float in that order. The radd will let me add them in the opposite direction. So this isn't necessary, but if we define our add method in this way, it makes sense to also define the radd method for consistency. Similarly, for the purposes of this exercise, I didn't need to define this dunder neg method. Right, but this allows us to give a meaning to minus a point. I negate both of the coordinates. Similarly, a submethod, I didn't need to define this more complicated procedure because we were only using points. Points and points. But again, well, I said let's allow this other possibility. And then similarly, because I added a perhaps richer submethod, I also said, well, I probably want to include an rsub method. Not necessary for this exercise, but mo method. Again, we needed this kind of definition because we wanted to multiply a point by an int or float and get a point, multiply a point by a point, and we get an inner product, which is a number. And again, I didn't need an rmul method, but I said, oh, well, why not? This allows me to multiply an int or float by a point and get a result. And then, of course, we wanted this distance function to compute a distance between 2 points because, well, we wanted to use this distance method in this clustering procedure later on. Right, and defining a distance function, well, just lets me make these kinds of function calls now. I don't have to compute the distance in this if statement. I just call the distance method and the points know what to do to give me a number. So again, adding all this functionality, all right, it's a lot of work to define it. Want to make sure it's defined correctly, works consistently, correctly, and so on. But having done that, well, then I might reuse this point class in other notebooks. I might I might copy and paste this code. Let's see if I could do this. I'll come out here, I make a, well, text file would work. Copy this code. Let's call this points.py. Save it. Make a new notebook in the same folder as this point script. I could import point. Oh, sorry, from, all right, from, all right, let's do this the right way. Let's rename this with a lowercase p. I'll say from point import capital point. And then I could use this class. PT1 is this, oops, PT1 without a space. Right, so I could add this code into a text file. This is basically a Python script. Now that I've added this in a text file, I can import this class from this script. In some sense, I've started to make my own library. So I can import this point class from this script, and right then I can say point 12,3 plus point of minus 10,4 and add, and I get a result. Right, so this is the value of writing your own class, is that I could basically save this code into another file, and then I can import this class from this file and use it in other applications. Right, PT1 distance to point 1, 0. Oh, sorry, I need to make this work. I'd want to from math import square root, so that this script would know about this. I want to restart my kernel. Re-import, and then my distance function works because I've imported the square root in this script right here. So that this script knows about the square root function. Right, so as I said, this is basically starting to write my own library of reusable code. Which I could then just import this class from this other module, this other library, this other file, and I could then use this class in other programs. All right, we're done for today. We're out of time. I will see you all tomorrow. Bring your questions tomorrow. I'm going to have no particular agenda for tomorrow except to be here to answer your questions. So bring your questions.